Okay, so this is the first video using two-way ANOVA, and it is going to follow the example in the slides right here on the gas consumption. This is the example that comes from Bloomin', and it's kind of a toy example because, like I said, you would never, ever, 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 ever do an analysis like this using, this small a sample. Typically, you'd have, at least 20 or usually dozens, if not hundreds of data values. So it's kind of a toy example, and interestingly, there's going to be some inconsistencies, and I want to point this out because I probably will forget to mention it in class. The way that sum of squares is computed can actually be done slightly differently. There's actually 4 what's called types. So you do see discrepancies, and you will see discrepancies kind of all over the place. You don't see these in one-way ANOVA because in one-way ANOVA there's only one way to calculate the sum of squares really. But when you get to higher level ANOVAs, you will actually see, and you can see it in SPSS, there's a place where there's a pull down and you can actually change the sum of squares type. They don't differ by a lot. You generally don't get different significances, but you will get slightly different like actual numbers in the sum of squares. So anyways, what I'm going to do is repeat here this example, which is the one we looked at from the book. And I type the data into SPSS. And like I said, this table here is what I'm sort of reproducing. It's not going to be exactly the same as Bloomin' because that's just not how it's going to happen in ANOVA. And to some extent, there's no sort of right or wrong way. Interestingly enough, I'll probably say this in class, is that the Bloomin' textbook does not explain how they got these actual calculations. So it's not actually there. Okay. So now I'm going to go into SPSS and open the data, and hopefully I can remember the data. It's the CARS MPG data, I think it is. Let's hope this is the right data. Yes. So this is the CARS MPG data, and we have CARS. Oh, this is not the right data. Hang on. Be careful because I don't know how. Well, it kind of happened just because I had some examples that were nice and they just turned out to have similar themes. This is not the CARS MPG one. That was from One Way ANOVA. This is the MPG example 12.5. It says example 125 is example 12.5. So this is this data set. It deals with MPG as an output, but this is the data set on the different types of gasoline versus the two-wheel or all-wheel drive cars. Okay. So this is the data from the Bloomin' example, and what we want to do with this is we want to run a two-way ANOVA because there's now 2 factors, gas and type, and 1 output measure. So initially what you're going to want to do is you're going to go to analyze and kind of like look for where to do this. Well, it's not under compare means. The one-way ANOVA is a direct means comparison test. So it's under compare means. The two-way ANOVA and anything higher goes into what we call a general linear model, and this is where we're getting into far more advanced statistics. And the general linear model is what we want to use. Now, univariate, multivariate, repeated measures here, this refers to the number of output metrics. You only have 1 output metric. So univariate refers to MPG. There's 1 output variable. There is such a thing as multivariate output. There's also such a thing as repeated measures, which is actually, if we had more time in this course, this would be one of the next things that I would teach. What repeated measures is that if you are observing something over time, and let's say that you assess them at 0 weeks, 2 weeks, 4 weeks, over some sort of treatment course, you can actually analyze the changes over time with that. I'm pointing that out because that tends to be something that is actually particularly used in psychology and fields like that. And medicine, of course, we do repeated measures analysis. So the general linear model univariate, that is the only feature that you have to worry about. And like I said, this is getting to be the end of this course, so this is one of the last. But now at this point, you look at this analysis screen, and you can recognize about half the things on here as something that you've done a little bit with. So general linear model, univariate, general linear model, univariate. This is where you go to do your two-way ANOVAs, and if you were doing ANOVAs beyond 2 ways, this would be where you go as well. And then you get the screen here, which really isn't too bad. Dependent variable is always your y variable. That's always your outcome. So there's only going to be one outcome, so that's good. And then you have these factors. Now I have to admit the truth, the whole truth, and nothing but the truth. For the life of me, I have never fully understood the difference between a fixed factor and a random factor. There's a funny, subtle discrepancy between fixed and random factors, and it just never made a whole lot of sense to me. But for this analysis, you're just going to use fixed factors and don't worry about what a random factor is. I admit that's just one thing that I just never understood. And so these are going to be your factors because it's a two-way ANOVA and you have two factors. Now, all of this other stuff, let's ignore it and just run this once for now. You can see the postdocs in here. Postdoc, of course, is going to get more complicated than with one-way ANOVA because now we've got different things on here. And then you're going to hit go. Okay. And so we get what does initially this doesn't look like an ANOVA table, but it is. This table here has all kinds of things in it, but like I highlighted in the notes and the PowerPoint slides, there's only a couple things you need to look at. And for your purpose, what you're looking at is the gas, the type, and then the interaction. So this row, and this row, and then whether they're significant, okay? So the gas is at the 5% level, it's not significant. The type is significant and the interaction is significant. And it is in fact the case that you can have a significant interaction when the input variable itself or the factor itself is not significant. And that's kind of what we're seeing here. So even though the type of gas doesn't seem to matter with respect to miles per gallon output, the interaction of the type of gas with the type of car matters. And that's a little bit complicated to understand. With type, it was like, I forgot exactly what this was, admittingly. Two-wheel drive, four-wheel drive. So what they're saying is that across all cars, not with respect to two or four-wheel drive, whether you use regular or high-octane gas doesn't matter. Whether the type of car does matter, though, however, there's a difference between four-wheel drive and two-wheel drive. I don't know what the exact difference is. I think four-wheel drives are a little bit gas guzzler-y. But so, as if we looked at each of these as one-way ANOVAs, and let's actually do that. It's a little difficult, though, because you're not, when you decompose this into just looking at type and just looking at gas, it's not like it's going to be just this value here. So let's just actually do this. Let's do a one-way ANOVA on each of these factors individually. And you can do that. I mean, there's no reason, just because you have multiple factors doesn't mean you have to do it two-way. Well, you do for the assignment, but you can look at individual factors. And so let's look at gas by itself. This is the simple way of doing ANOVA. It's the means way, and I just have to make sure I have this checked off. To do gas by itself, hit go. And gas by itself is not significant. This is just the gas by itself. These are the means of 28, 27. You can see there's not a lot of significant going on here. There's not, these values here are not like the same as these, and they shouldn't be. It doesn't work that this is just you can't just decompose this and use these 5.4 as the sum of squares. It doesn't work that way. Although actually it kind of does in this respect. The 5.4, sorry, this number here is actually the same, the 5.4. I don't believe the F ratio of 4.8 is the same. No, see, the F ratio is completely different and the significance is different. So the sum of squares actually does turn out to be the same, sorry, because it's going to be the same as we calculate the one-way ANOVA, where you're going to look at the individual data values minus the means, and then you could actually do this one by hand. I'm not going to, but some of the values are the same and some of them aren't. So it's not really like this table is not a composition of the individual tables, is what I'm trying to say. Anyway, so that's gas by itself. Let's look at type by itself. So type by itself is going to be compare means, and then we have, let's get rid of gas, put in type. I think the ANOVA is already going to be checked off, so we're good. And then, so type by itself is also not significant, interestingly enough. So this is actually a really important thing to point out, which is that, you basically it's saying that neither one of these are significant in of themselves, but if you throw them all together and look at the interaction, then it is going to be significant. So really, the essence of this analysis is not really that there's a significance in miles per gallon by gas or by car type, but that the interaction of the gas times the car type is what creates a significant effect. In other words, regular versus high octane and two-wheel and all-wheel drive cars, there's a difference in how they behave. Um, so the type is marginally significant when you throw it into the more complicated model, but really it's this interaction that is kind of the star of this analysis in terms of the significance. Okay, so that is how to run the two-way ANOVA, and again, it's under Analyze, General Linear Model Univariate. Now, what we also want to do, and I hope I can remember how to do this, is we want to do the interaction plot. Okay, and so the interaction plot, I don't know where it went. Hang on, it's getting late. It's part of this. It's under General Linear Model, Univariate, and then it's under Plots. Okay. Now this is a little complicated. Okay. So it's under the General Linear Model and then the Plots button, and then the reason it's a little complicated is you can actually do this in two ways, and then you have to do this. I find it very non-intuitive. So horizontal axis gas, and then separate axis type. You could, of course, do these in a slightly different way, and then we could do like separate plots. But then it gets crazier because to do the interaction plot, you got to do this. And I think this is one thing in SPSS that I find incredibly non-intuitive. So they call it it's the profile plot, which I call it the interaction plot. So we have the two factors, horizontal and then separate lines, but then you have to cross them. So the one that's entered horizontal first becomes the first cross, and this one becomes the second cross. These are the same variables. They're not going to be the same plot. So I have gas times type and then type times gas. So I'm interchanging my X and Y axes. So I'm going to run both of these. It's kind of common to run both of these, by the way, just because it's kind of interesting to look at it this way. So I'm going to run both of these, and then we're going to see how this goes. And so I'm going to hit go. It's going to run the analysis again, but it's these plots I want to look at. So here we have the two profile plots. One of which is, you can see the difference is that the first one has, the means here are the average miles per gallon by car type. This is the two-wheel and the four-wheel, and then by gas on the x-axis. So you can see very clearly the interaction going on here in that for the high octane gas, the two-wheel drive cars get better mileage and the four-wheel drive cars get worse mileage. And the big thing about this is that the interaction going on, because for the regular gas, the opposite effect is true, which means that the four-wheel drives get better mileage than the two-wheel drives. So you can clearly see that it's not really the difference, the MPG difference is, sorry, I just goofed and put this down. The difference, it's not these individual differences we really care so much about. It's the fact that the cars behave differently by the interaction of what kind of drive type and what kind of gas type. And it is kind of interesting to look at these things. I have to say that they're really kind of they're really fun actually to analyze this kind of stuff. And so you can see that there's an interaction going on. And interactions are not trivial. I mean, there's something really seriously important because if you have, for example, gender is a perfect example of this, and very often you will see that something behaves differently in males and females. And this analysis would show you, pretty clearly and pretty simply that, the males and the females, there's something going on. Like one treatment works better for males and one treatment better for females. It's a pretty common thing to have these interactions. They're not like something that's kind of unusual, and they're really important not to ignore, because you don't want to. Very often, we sort of give a drug to people at random or a treatment or something, and you have to pay attention to the fact that different races and different genders behave differently for whatever reason, genetic reasons, lifestyle reasons, or just whatever. And it's really important to look at interactions. So the second plot is, if you pay attention to the x-axis here, this one is the y-axis here is the mean based on type, and the x-axis is the gas. The other one is the other case around. So, I mean, you see the interaction in both cases. It's just the way they're plotted is they're two different plots. In this case, the plots look the same. If you do these with more than one factor, you start to get plots that look different, and they're a little more hard to interpret. The two-way plots are quite straightforward. When you get, if you have, for example, more than two types down here, you can have kind of these like wiggly type patterns. But anyways, you clearly see the interactions, and again, the whole two-way analysis, two-way ANOVA is under general linear model, univariate. Don't worry about playing around with the model types. Oh, one more thing. This is what I was talking about with the sum of squares. There are slightly different ways of calculating sum of squares, so you do get some discrepancies in ANOVA tables for higher level ANOVA models, but just don't touch this. Just leave it. So for your purpose, you just have to pull this down, make sure that you set the output variable, the two factors go in here, keep them as fixed factors. And if I ask you to do the plots, do the plots. The way that I did that is basically just one goes on here, and the other one here, and then add, and then do the reverse. And so, in many cases, you do want to look at both plots because they don't really convey quite the same information. They're sort of inverses of each other, but not really. And so that is the first example of the two-way ANOVA. It's not bad stuff. Don't worry, we'll get there.